Artificial lift rod pump well completions comprise by far the largest number of well mechanical completion designs in the industry. In many cases, a rod pump may contribute only a very small daily net oil rate, but there are a very large number of rod pumps working 24/7, 365 globally. A broad web search of rod pump data leads to the conclusion that the world's population of producing wells is around 1 million. Of these wells, between 90% and 94% of them are on artificial lift, and of these, about 85% to 90% are estimated to be rod pump type completions. So, just looking at the above approximations leads to the conclusion that rod pump units dominate, in total number of units, the industry's oil production output. Modern-day cost-effective digitalization and data transmission capabilities outlined in the module make it possible for rod pump performance data to be streamed live into operations office locations, either proximate to wells of interest in question or across long distances far from actual rod pump well field locations. Thus, it is possible for both operations engineers and service organizations to be capable of viewing and identifying in real time both optimized wells needing little or no attention and problem wells requiring remedial action. This module reviews in detail the design and operation engineering and principles of a rod pump's surface unit, rod string, and downhole rod pump, the three primary components of a rod pump completion. The standard rod pump performance analysis tool, the surface dynamometer, is presented in detail, which permits the student to understand how surface data may be used with sophisticated wave equation differential equation mathematics, how a downhole pump and the overall unit is performing. Well site controller technology is introduced, as well as corrosion control principles for rod pumps. Failure analysis is presented as a method to reduce pump failures, downtime, and remedial costs. Learning how an operations engineer responsible for rod pumps can take advantage of the available analytical tools to maximize production from a rod pump while minimizing undue stresses on the surface unit, rod string, and downhole pump components will result in minimal pump failures and greatly reduced operating costs and downtime.